Hello. Welcome, everyone. Welcome. Good morning. Today, I'm going to be talking to you about Polkadot and Substrate. My name is Emre. I'm from the Web3 Foundation. There, I'm a technical educator. So hopefully some of you are maybe familiar with these things. If not, this is okay for you. So our founders, Gavin, Robert, and Peter, founded Polkadot, wrote the white paper in 2016, so it's been about 5 years, 6 years almost. Gavin and Robert are still working full-time on this project. Peter has since moved on. So this Web3 paradigm, we have a vision in that, and we want to believe in a decentralized internet where people own their own data, their identity, and hence their destiny. So this is our kind of philosophy that we share between the Web3 Foundation and Parity. Between the two, the development of Polkadot, research, education, grants, and everything gets handled. So Polkadot is this layer 0 heterogeneous multichain. We believe the future is multichain, and Polkadot provides that foundational protocol for that future. What we mean by that is we have things like Ethereum, we have things like Bitcoin, and these are these L1 chains that have applications running on them, or they're like application-specific services, whether it's privacy, identity, DeFi, whatnot. We see those as kind of these isolated networks that can't communicate with one another, therefore you can't really compose them together to create new ideas. So Polkadot is going to be the layer that sits underneath these things and allows the interoperability of these L1s. So the way that we handle that is with this scalable architecture that we've developed, which is the relay chain and parachains paradigm. So we have the relay chain, which is the main chain, where we have validators running proof of stake, nodes to create blocks and have transactions. And so what is really special about the relay chain is it allows for L1s to connect to it. These are the parachains. So application-specific blockchains that are, consensus agnostic as well, can connect to the relay chain, and now any of the connected L1s can communicate with one another and interoperate with one another. And in Web3, what we would like to see is the composability of these L1s. That's when the real power of these networks is going to really come through and have more general adoption. So the power of Polkadot lies in its shared security. Before this type of architecture, you had to either buy into a smart contract platform and release a token, and you would have to kind of abide by their rules, or you would have to build your own network from scratch, which takes a lot of time and development effort, etc. Polkadot allows any idea to just connect to it. This therefore shared the security of Polkadot, which is already established. So if you have an idea, this is a really good way to test out your ideas, right? So you don't need to build your own network anymore. You don't need to abide by certain rules of smart contract platforms anymore. You can develop your own consensus and application-specific chain, and then just connect to the security of Polkadot. Scalability, this is kind of our version of sharding, these parachains, right? Sharding is kind of a topic and a way of scaling blockchains, which we need to be able to do. With parachains, we're able to scale quite indefinitely. Even if we go to 100 parachains on the relay chain, we're thinking about ways to create nested relay chains. So the ceiling of scalability is quite high. And the interoperability, think of interoperability as kind of like what TCP did for the internet in the 70s, right? So TCP allowed IPs to pass back and forth data packets. And it was like kind of the shared protocol, right? This is exactly what Polkadot is trying to do as well. With XCM, which is the cross-consensus messaging format, you can create any type of messages, arbitrary data, transaction data, identity data, proof of something, and pass it around between these parachains to the relay chain, etc. And one huge improvement that Polkadot brings to the table is this idea of forkless runtime updates, right? Before you had to fork your chain to create breaking changes. What we use is WASM blobs, so WebAssembly blobs. You can have your runtime as a WASM blob, you upload it to the chain, and then it goes through governance, which we'll talk about. And if it gets accepted by the token holders, it's going to get included in one of the upcoming blocks. And as soon as that block happens, your runtime is kind of happening. There's no fork needed. And we also have this really cool network called Kusama. Some of you might have heard of it. It's our canary network. It's been talked about as kind of like this wet value-bearing test network, right? With these blockchains, we have these economic ideas, these game theoretic things that need to happen for us to test actual ideas. And test networks just don't cut it, right? So we need to have like real value networks in which we can test these ideas. This is what Kusama does. And Kusama is actually starting to become its own kind of full-fledged network. Some projects are actually choosing to stay on Kusama and not go on to Polkadot. Not the other way around. So there's no projects that wouldn't go directly to Polkadot before testing on Kusama. Hopefully, we'll see. So the DOT token is really like the center of all these things. It's a utility token that allows for participants to stake their token, become validators, to participate in governance, so like voting for these runtime updates, and ability to participate in parachain slot auctions and crowd loans. So we're going to dive into that as well. So parachains require slots, right? So the relay chain has these slots. So how do we give away these slots? We need to make sure that the ones that are participating in these parachain slots are chosen by the community, valuable projects. So what they can do is run a crowd loan. A crowd loan is a way for them to signal their the community's interest on how much they want this parachain to be a part of the network. So they fundraise through the crowd loan. And then they're able to take a part of the auctions using these funds that they raised through the crowd loan. And the Polkadot network auctions off lease periods. So there's a certain amount of time the parachain stays on the relay chain, and then when that lease period is over, they have to keep occupying it by running into new auctions. So governance, this on-chain governance idea of Polkadot is super powerful. Token holders are able to now have say in how the network gets developed. And this is really powerful because any changes to the network, any runtime updates, has to pass governance first. This is decentralizing further than, let's look at Bitcoin, for example. Developers are able to create updates all the time, depending on like what they see fit. But with this model, token holders actually have a voice. So they do this through public referenda, and the network uses adaptive quorum biasing. So it's a way to adjust the quorum based on voter turnout. So if it's low, it adjusts. If it's high turnout, it adjusts. If it's regular turnout, it adjusts. So that makes it a little bit more fair. So that the quorum is not just some arbitrary value that's set by something. And then there's the on-chain treasury. So this is a really powerful funding mechanism for on-chain funding. There's been ideas, there's been projects, there's been books that have been funded through this mechanism. So the consensus on Polkadot is a nominated proof of stake. That's the kind of the validator election mechanism. And then we have what we call BABE, which is the block creation mechanism, and then we have Grandpa, which is the finality module. So this altogether works together to be a hybrid consensus. So it's a deterministic finality with Grandpa. It's able to make sure that it has some like assumptions baked into it, and if there's like 2/3 of the nodes that agree to something, that's good enough for Grandpa to start adding blocks. But let's say there's less than 2/3, some nodes are misbehaving, the network is able to fall back to a probabilistic longest chain finality with Babe. Okay, so that's Polkadot. Let's dive into Substrate. So Substrate is the framework that Polkadot is built on. It's written in the Rust framework, Rust language, and it provides all the core components that a blockchain might need in what are called pallets. So over the course of the decade that has passed since Bitcoin, developers have realized that there's some of these pieces of code that need to be repeated. So Substrate provides pallets. And those are like the database layer, the networking layer, the consensus layer, the transactions, the runtimes. Those are all included in pallets. So Frame is also a framework within Substrate, so a framework within a framework. Frame allows a set of pallets and supports libraries to simplify the runtime development. And so storage, dispatchable, events, errors, and configuration can be done easily with the framework. So pallets are these things like babe, grandpa, elections, multi-sigs, assets. You can kind of use these as building blocks, kind of like Legos, to develop your parachain. So your runtime, aka your state transition function, is a collection of these pallets. And essentially, with these, you can develop any type of application-specific blockchain, and it would be able to run on Polkadot or Kusama. So adding pallets is quite simple. You can just include it into your config. We'll look into that when we run our own node in a second. And the layer of granularity that Substrate gives you is pretty large. So you can either run a Substrate node, use Frame to develop your own pallets, or you can use Substrate core, which is kind of, you can ignore Frame with that, and you can write your code in any WebAssembly supported language, and it can run on Substrate. So let's run a node. Cool, so I have two templates here. It's a front-end template and a node template. These are kind of like out-of-the-box starter packs for Substrate. So first, what I had to do is I had to compile the Substrate node template before coming here, because it takes a little bit of time. So I'll include like resources at the end of this. People, if they want to like install Rust, run Substrate. But I'll just start the node in developer mode. So out of the box, what comes is a proof of authority network. So you have pseudo power. Your node, single node, is able to run, it has an account. The Alice account is kind of like the super user account. So you can do whatever you want. Right now we're building blocks on this proof of authority network. And then Polkadot, when it first started, was a proof of authority network. And then Web3 Foundation ran the nodes, and then introduced governance, and slowly, as there was enough signal for interest to become validators from the community, we saw that, you know, okay, this is decentralized enough. Now the network is up to the token holders. And with governance, nominated proof of stake was released, and proof of authority was removed. So right now we're building blocks. Let's start our front end. So this is a simple front end to just kind of like show us exactly what's going on this node that we're running. So with the node, you're going to see the blocks generation and the accounts that get created. So what's interesting here is we can see the pallets in our metadata. So remember, the pallets are these building blocks, like the Lego blocks, right? So we have a pallet called account. We have a pallet called extrinsics count. So one thing that's interesting in Substrate is we have this idea of existential deposit. If your account has less than a certain amount of tokens in it, it gets reaped, kind of like this garbage collection. Block hash, parent hash, digest. So all of these are modularized kind of portions of the blockchain that are doing these things. And you can pick and choose what you want to include in your blockchain when you're building with Substrate. Great. So let's do something. So let's say we just want to transfer some funds from Alice to Eve, right? Transfer the minimum amount, 1 unit. Great. So what's going on here is we're going to see some events. Substrate is a very event-based programming paradigm. So you can include events in your pallets. These events are really helpful for kind of your runtime, right? So we're going to see the balances palette use the transfer function, right? So there's a transfer going on here, and then all of these function calls in Substrate are called extrinsics, right? So these extrinsics are going to be defined within your palette. Your palette is going to be able to define any custom extrinsic that you want, and then you can actually build events around that. And based on those events, your code might want to do something else, right? So you also want to make sure that there's solid error handling there. We can dive into one of the palettes in a second, but so this extrinsic was a success, and now the funds have been transferred to Eve. Okay, so let's use one of the other palettes, right? There's the systems palette, right? So with this palette interactor, we can see all the extrinsics on a palette. So if we go to, let's say, system, we have a remark. So system.remark is a way to include data inside of a block that's not included on the on-chain try, which is the database. So Substrate uses some optimized blockchain, optimized database solutions. Mostly it's just trees. So with this, it's not included in that database. It's included in the block. So if a node is going to start running a full block, it's going to be included in the blocks database rather than the try that takes care of like transactions. And so it's going to, on this UI, expect some bytes. So I'm going to actually just write something. So I'm just going to say Emre was here in bytes as a signed transaction. And we're going to see that this extrinsic was a success. And it's in the block. And we're going to wait for grandpa finality right now to tell us which block that it was included in. Finalized block hash, cool. Now, we have some data that's baked into that block, right? So we should be able to go open that block and see what's in there. So I'm going to open up my favorite tool, Polkadot.js. So Polkadot.js is ability, it's a UI. Polkadot.js is actually a collection of tools. It has an API, it has a UI, it has an extension. But it also allows you to connect to that local node that you're running. So this is great for development. Great, so I can actually look at the network through the Explorer, and I can see my blockchain live creating blocks. I can actually look at this block that I put the remark in, and you can see all the extrinsics that happened in a block. So function calls are included in blocks, and we can see this system.remark extrinsic that I called, in which the bytes that represent Emre was here is included, right? So essentially, I'm baked in history. So with these things, it's pretty easy to just spin up a blockchain now. Pretty powerful stuff. Like, you don't have to worry about network development. You don't have to worry about anything that has to do with networking. You just focus on your application and what you're trying to solve with your blockchain. Cool. That's it from me. Thank you, everyone.